There is a moon in our solar system with an ocean larger than every ocean on Earth combined, buried beneath a shell of ice, and scientists believe it might be one of the best places to find life beyond our planet. There is another moon that spews ice into space so violently it creates one of the rings of its own planet. And there's a moon so strange that it has its own atmosphere, its own weather, and rivers made not of water, but of liquid methane. For centuries, moons were considered lifeless, frozen leftovers orbiting the true stars of the solar system. But over the last few decades, spacecraft after spacecraft has revealed something astonishing. Some of these so-called dead worlds may be more alive, more active, and more mysterious than the planets they orbit. Today, we uncover 10 discoveries about the strangest moons in our solar system. Discoveries so unexpected that they force scientists to completely rewrite what we thought we knew about space itself. For most of human history, moons were an afterthought. Earth had one, gray and silent, and it seemed reasonable to assume that other moons throughout the solar system would be just as still and lifeless. When early telescopes revealed moons orbiting Jupiter and Saturn, astronomers assumed they were simply smaller, colder versions of our own. There was no reason to expect anything more. Yet as space agencies began launching probes deeper into the solar system, starting in the 1970s and accelerating through the Voyager and Cassini missions, something remarkable started happening. Every time a spacecraft got close enough to photograph a moon in detail, scientists found something that should not have been possible. Instead of dull, cratered rocks, they found volcanoes, oceans, geysers, and atmospheres, sometimes on moons smaller than our own. The unassuming little worlds circling the outer planets turned out to be some of the most dynamic and scientifically important objects in the entire solar system. To understand why this shift mattered so much, you have to remember the assumptions that shaped early planetary science. Moons were expected to be geologically dead because of their small size. Smaller worlds cool faster than larger ones, and without internal heat, there should be no volcanic activity, no tectonic movement, and no liquid water. This was simple physics, and it made perfect sense on paper. But nature, once again, proved far more creative than the models predicted. Many moons orbiting gas giants experience something called tidal heating, a process where the immense gravity of their host planet stretches and squeezes them as they orbit, generating enormous internal heat through friction. This single discovery unlocked a completely new category of worlds, moons that should have been cold and dead, but were instead warm, active, and in some cases, capable of supporting the conditions necessary for life. The first major discovery came from Jupiter's moon Io, observed up close by the Voyager 1 spacecraft in 1979. Scientists expected another cratered rock, but instead, cameras captured something never before seen on any world beyond Earth, an active volcanic eruption caught in the act, blasting material hundreds of kilometers into space. Io turned out to be the most volcanically active body in the entire solar system, far surpassing Earth, with hundreds of volcanoes constantly reshaping its surface. The intense gravitational squeezing from Jupiter generates so much internal heat that Io's surface is constantly melting and refreezing, creating a landscape that looks almost alien even by solar system standards. The second discovery came from Europa, another moon of Jupiter, whose icy surface initially seemed unremarkable until scientists studied the cracks and patterns etched across it. These fractures suggested that beneath the frozen crust lies a vast liquid ocean, kept warm by the same tidal forces affecting Io. Later missions estimated that Europa's ocean may contain more than twice the total volume of water found in all of Earth's oceans combined, hidden beneath an icy shell just a few kilometers thick in some areas. This transformed Europa from a forgettable ice ball into one of the most promising targets in the search for extraterrestrial life. The third discovery involved Saturn's moon Enceladus, which stunned scientists when the Cassini spacecraft detected geysers of water ice erupting from cracks near its south pole. These plumes shoot hundreds of kilometers into space, and some of that material even helps form one of Saturn's outer rings. Analysis of the ejected material revealed organic molecules and the chemical ingredients necessary for life, hidden inside a liquid ocean beneath the icy surface, once again defying the assumption that small, distant moons must be geologically inactive. The fourth discovery came from Saturn's largest moon, Titan, revealed in extraordinary detail by the Cassini-Huygens mission. Titan turned out to have a thick atmosphere, denser than Earth's own, along with rivers, lakes, and even rain, but instead of water, these features are made of liquid methane and ethane. Titan remains the only place beyond Earth where confirmed liquid exists in stable form on the surface, making it a bizarre mirror of our own planet's water cycle, just with different chemistry entirely. The fifth discovery involves Neptune's moon Triton, which orbits its planet backward compared to nearly every other large moon in the solar system, a strong sign that it was not born alongside Neptune, but was instead captured from elsewhere in space. Even stranger, Voyager 2 detected active geysers of nitrogen gas erupting from Triton's frozen surface, despite temperatures colder than almost anywhere else observed in the solar system, proving that even the coldest, most distant moons can still surprise scientists with unexpected activity. The sixth discovery focused on Saturn's moon Iapetus, famous for its bizarre two-toned appearance, one hemisphere dramatically darker than the other, almost as if painted by an unseen hand. Scientists eventually determined that dark material from another moon slowly falls onto Iapetus, absorbing enough heat from sunlight to sublimate ice on that hemisphere, exposing even darker material beneath, while the opposite side remains bright and icy, creating one of the strangest and most visually striking objects ever photographed in space. The seventh discovery involves Jupiter's moon Ganymede, the largest moon in the entire solar system, larger even than the planet Mercury. Scientists discovered that Ganymede has its own magnetic field, a feature no other moon possesses, generated by a molten iron core deep inside. Evidence also suggests a saltwater ocean lies beneath its icy crust, layered between multiple sheets of ice in a structure unlike anything else observed, making Ganymede far more geologically complex than most planets, despite technically being nothing more than a satellite. The eighth discovery came from the tiny, irregularly shaped moons found orbiting asteroids and dwarf planets, once dismissed as insignificant debris. Detailed observations revealed that some of these moons formed from massive collisions, offering scientists crucial evidence about the violent, chaotic processes that shaped the early solar system, essentially acting as frozen time capsules recording cosmic collisions from billions of years ago. The ninth discovery involves the unusual moons of Mars, Phobos and Deimos, which scientists now believe were likely captured asteroids rather than moons that formed naturally alongside the planet. Phobos, in particular, is slowly spiraling closer to Mars and is expected to eventually break apart, potentially forming a temporary ring around the planet, a fate no one predicted when it was first discovered. The 10th and perhaps most unsettling discovery is the growing realization that dozens of moons across the solar system may harbor subsurface oceans, meaning that liquid water, the essential ingredient for life as we know it, might actually be far more common throughout the solar system than the surfaces of these worlds ever suggested. Instead of a handful of potentially habitable worlds, scientists now believe there could be an entire hidden network of ocean worlds scattered across the outer solar system, each one a sealed chapter waiting to be opened. These discoveries completely reshaped how scientists approach the search for life beyond Earth. For decades, the search focused almost entirely on planets located within a narrow habitable zone, the region around a star where temperatures allow liquid water to exist on the surface. But moons like Europa and Enceladus prove that liquid water can exist far outside that zone, hidden beneath ice, warmed not by sunlight, but by the gravitational squeezing of a massive host planet. This single realization dramatically expanded the number of potentially habitable worlds throughout the universe, suggesting that moons, not just planets, might be common hosts for life. The impact reaches beyond scientific curiosity. Space agencies have redirected billions of dollars in funding toward missions specifically designed to study these ocean worlds up close. Spacecraft are now being built to fly through the icy plumes of Enceladus and land on the surface of Europa, searching directly for signs of biological activity. What was once considered a fringe idea, that life might exist on a moon rather than a planet, has become one of the most funded and actively pursued questions in modern astronomy. Of course, not every mystery has been solved. No mission has yet confirmed the presence of life on any of these moons, and some scientists urge caution, reminding the public that liquid water alone does not guarantee biology. The chemistry required for life to actually begin remains poorly understood, even here on Earth. Still, the mere possibility that oceans exist just beneath the surface of these distant, icy worlds has changed the entire conversation, shifting the search for life from a distant hope into an active, testable scientific pursuit. Perhaps the greatest lesson from these discoveries is not about the moons themselves, but about how easily assumptions can blind us to reality. For generations, scientists looked at small, cold, distant worlds and assumed there was nothing left to learn. It took decades of patient exploration, powered by curiosity rather than certainty, to reveal oceans, volcanoes, atmospheres, and geysers hiding in plain sight the entire time. The moons of our solar system, once considered footnotes in the story of space exploration, have become some of its most important chapters. If these discoveries changed the way you think about the moons quietly orbiting the planets around us, consider giving this video a like. It helps more curious explorers find stories like this one. Let us know in the comments which of these moons surprised you the most, or which mysterious world you would like us to uncover next. And if you want to keep discovering the strangest, most unexpected secrets hiding across our solar system, subscribe to the channel, because some of the most incredible worlds are still waiting to be explored.